Boots Void. The Boots Void is a cosmic dead zone so empty that astronomers literally nicknamed it the Great Nothing. This isn't just a quiet patch of sky. It's a super void stretching over 330 million light-years across. For scale, that's big enough to swallow thousands of Milky Ways and still have room for dessert. But instead of being jam-packed with galaxies like most regions of its size, Boots Void holds only about 60. That's like showing up to a music festival and finding 6 people. Discovered in 1981 by Dr. Robert Kirshner and his team, the Boots Void was so unexpected that scientists double-checked the universe to make sure it hadn't just glitched. Its eerie, spherical shape made it only weirder. It's like the cosmos carved out a perfect hole and then forgot to fill it back in. At 700 million light-years away, it doesn't threaten us directly, but its existence raises big questions about the structure of the universe, dark energy, and even, if you really want to go down the rabbit hole, the idea that these voids could be connected to other universes. Bottom line, the Boots Void is like finding a haunted mansion in the middle of Times Square. It shouldn't be this empty, and yet it is. Ton 618. If the universe had a final boss, it'd be Ton 618, which is a quasar so far away, so luminous, and so ridiculously massive that it feels less like an astronomical object and more like a cosmic middle finger to the laws of physics. Sitting at 18.2 billion light-years from Earth, Ton 618 is distant and ancient. The light we see from it started its journey when the universe was barely out of diapers, and yet, even from that unfathomable distance, it still shines brighter than entire galaxies. Why? Because it's powered by a 66 billion solar mass black hole. That's a black hole big enough to swallow our entire solar system and still have room for a second helping. As a hyperluminous quasar, Ton 618 is the cosmic equivalent of a lighthouse strapped to a nuclear bomb, blazing with so much energy that its surroundings look dim by comparison. Located near the constellations Cons Venatici and Coma Berenices, Ton 618 is visible to the naked eye, but every time astronomers point a telescope at it, it practically screams across the void, "I am the void." What makes it strange isn't just its size or brightness, it's that something this monstrous even exists. Ton 618 is a real-life cosmic horror story, just sitting quietly at the edge of known space, feeding on matter and making the rest of the universe feel woefully underdressed. The cold spot. There's a scar in the sky, not one that you can see with your eyes, but buried deep in the ancient radiation echo of the Big Bang. It's called the cold spot, and it's like the universe took a hit. It's a massive, unexplained drop in temperature smeared across a region hundreds of times larger than the full moon. This isn't a glitch in the telescope, it's a legit anomaly in the cosmic microwave background, or CMB, a region that's 70 microkelvins colder than its surroundings. That may sound small, but in cosmological terms, it's like finding a single goosebump on the surface of the sun. It's huge, covering a region 1,500 times the size of the full moon, and it sticks out like a bruise on an otherwise evenly freckled cosmic skin. The cold spot breaks all the rules. According to every model we've got, it shouldn't exist. Temperature fluctuations in the CMB are supposed to behave nicely, but this one doesn't. It's a cosmic bruise that makes physicists twitch. Some blame a supervoid, a giant nothingness blocking the light in front of the CMB. Others whisper about quantum weirdness, multiverse collisions, or some physics we haven't invented yet. Or maybe, just maybe, the universe is trying to tell us something, and this cold patch is its first uncomfortable whisper. Suppose you understood that. You're too deep to back out now. You might as well subscribe to Whisper Back. The Galactic Graveyard. Every galaxy has its glittering stars, its nebulae, its swirling arms, but lurking just beyond that dazzling light show is a cosmic underworld, the Galactic Graveyard. It's not a cemetery with tombstones, but it's a vast, invisible sprawl littered with the remains of dead stars, neutron stars, black holes, and the violent echoes of long-gone supernovae. These stellar corpses are what's left after the universe's heavyweights burn through their fuel and explode in brilliant final tantrums. What's left behind is either a neutron star, which is a city-sized chunk of degenerate matter, or a black hole. But here's the creepy twist. These remnants don't just stay put. Many get kicked out of the galaxy entirely during the explosion that created them. Like cosmic ghosts, they drift in the dark, undetectable to most telescopes, spread across a region far larger than the visible galaxy itself. Scientists recently mapped this galactic underworld for the first time, and it turns out it's 3 times larger than the galaxy we see. A silent swarm of stellar phantoms orbiting in the shadows, far from the galactic spotlight. It's strange, it's massive, and it's utterly silent. No light, no heat, just invisible wreckage from stars that died millions, sometimes billions of years ago. The Eridanus Supervoid. If the universe had neighborhoods, the Eridanus Supervoid would be the loneliest cul-de-sac in the cosmos. Stretching a mind-boggling 1.8 light-years across, this patch of space makes even the Boots Void look like Times Square. It's not just empty, it's cosmically barren, with far fewer galaxies than expected for a region that size. But it's not just the size that makes it weird. The Eridanus Supervoid is suspiciously tied to the CMB cold spot. Some scientists believe the supervoid might be responsible for the chill, affecting photons as they pass through with a process called integrated Sachs-Wolf effect. In short, light loses energy crossing the void because the region is expanding faster than its surroundings, possibly thanks to dark energy doing its creepy stretching act. This isn't a black hole, though. It's far from it. Supervoids are the universe's cosmic deserts, not dense pits. No crushing gravity, no time-warping weirdness, just a profound lack of everything, like the universe took a break from galaxy-making and never came back. Cosmologists are now poking around the Eridanus Supervoid, treating it like a natural lab for dark energy and early universe mysteries. But truth be told, it's still a huge question mark in a sky full of glowing dots. The Eridanus Supervoid, eerie, oversized, and possibly the universe's biggest missing content warning. XTE J1650-500. Black holes are usually the heavy hitters of the cosmos. Massive, greedy monsters that swallow stars like peanuts. But XT J1650-500? It's a cosmic paradox. It's one of the lightest black holes ever found, yet still terrifyingly powerful. Tucked inside the southern constellation Ara, this little menace lives in a binary system, dancing in a deadly gravitational tango with a companion star. The only reason we know it exists is because it's constantly feeding, ripping matter off its partner and heating that gas to millions of degrees. That glowing death spiral spits out X-rays like cosmic screams, which is how astronomers first spotted it. What makes XTE J1650-500 so strange is its size. With a mass of just 3.8 times that of our Sun, it's barely above the theoretical minimum for black holes. Any smaller, and it might have collapsed into something else entirely, like a neutron star. It's the cosmic equivalent of a bantamweight boxer who still punches like a heavyweight. Unlike supermassive black holes at the centers of galaxies, XTE J1650-500 is a stellar mass black hole born from the collapse of a single massive star. No galactic fireworks, no monstrous appetite, just stealth, hunger, and gravity cranked to 11. Blood Falls. If you stumbled across Blood Falls without context, you'd think Antarctica was leaking. This bizarre red waterfall gushes from the edge of the Taylor Glacier, spilling vivid crimson down an otherwise sterile white sheet of ice. It's not paint, pollution, or some ancient penguin curse, though. It's iron-rich salt water doing chemistry in plain sight. Discovered in 1911 by geologist Thomas Griffith Taylor, the falls pour out of the McMurdo Dry Valleys, one of the most extreme desert environments on Earth. Hidden beneath the glacier is a subterranean lake, trapped and isolated for millions of years. That lake is loaded with salt, iron, and surprise microbial life that doesn't seem to care if it's living in complete darkness, zero sunlight, and below freezing. Here's the trick. When the iron-packed water seeps out and hits the air, it oxidizes, which means it basically rusts on contact, turning the water a deep, eerie red. The result is this slow-motion horror movie effect that makes the glacier look like it's weeping blood. And that's not just a party trick. The extremophile microbes lurking beneath the ice offer a biological blueprint for how life might survive on other icy worlds, like Europa or Enceladus. So yeah, Blood Falls is a rare Antarctic waterfall that looks like it belongs on the set of a horror flick, but it's actually a natural science lab for studying ancient Earth, alien survival, and life where life really shouldn't be. Pillars of Creation. The pillars of creation look like ancient towers carved by celestial hands. They are majestic structures rising from the heart of the Eagle Nebula, some 7,000 light-years away in the constellation Serpens. But these aren't just space ornaments, they're stellar nurseries, colossal clouds of gas and dust where new stars are actively being born. Spanning up to 70 light-years, these pillars are shaped by violence. Radiation from nearby newborn stars blasts at them like a cosmic sandblaster, eroding their surfaces and sculpting those dramatic finger-like shapes. It's like watching a mountain melt in slow motion, except the mountain is made of hydrogen and the sculptor is a billion-degree photon storm. You've got to admit that they do look good in Hubble's image of them. Those towering forms, dark and dramatic, backlit by the fire of creation. But once you look at them in infrared, they become transparent and reveal the web of embryonic stars hidden within. It's then you realize that it's a birth scene, captured in slow motion over millennia. What's truly wild? They might already be gone. Light takes thousands of years to reach us, and there's evidence of a nearby supernova that might have vaporized the pillars 6,000 years ago. What we're seeing today could be a cosmic ghost, the last photograph of a structure that no longer exists. Neutron stars. If black holes are the universe's trapdoors, then neutron stars are its wrecking balls, small, dense, and impossibly extreme. These are the crushed cores of massive stars that went supernova, imploding into a city-sized sphere with the mass of the Sun. Imagine squeezing Mount Everest into a coffee mug. Now make it weigh 100 million tons per sugar cube, and you're just getting started. A neutron star is only about 12 miles across, but its gravity is off the charts. The atoms inside are so tightly packed that electrons and protons are forced together into neutrons, creating a bizarre mix of matter not found anywhere else. Some scientists even suspect the core might contain strange matter, where quarks go off script and rearrange into exotic states we've never recreated on Earth. And then there's the magnetic field, which is billions of times stronger than Earth's and strong enough to distort atoms and mess with the very fabric of matter. Combine that with insane rotational speed, and you've got a pulsar, a neutron star spinning hundreds of times per second, flashing beams of radiation like a cosmic lighthouse having a nervous breakdown. Neutron stars are what's left when a star dies in the most dramatic way possible, and instead of vanishing, they become one of the weirdest, most dangerous objects in the cosmos. WASP-12b. If there's a worse vacation spot in the galaxy, WASP-12b probably owns the title. This poor gas giant orbits so close to its star that it's literally being ripped apart. Dubbed a hot Jupiter, WASP-12b is about the same size as our own Jupiter, but that's where the similarities end. For starters, it orbits its star in just 1.1 Earth days. That's not a year, it's a work week that forgot to stop. It's so close, the star's gravity is stretching the planet into an egg shape and siphoning off its atmosphere like a leaky air mattress. Temperatures on the day side reach 4,600 degrees, which is hot enough to melt steel, glass, and most of your sanity. But here's the thing, the planet absorbs almost all visible light. Instead of glowing like a torch, it just sits there, pitch black, like a charcoal briquette in a blast furnace. Astronomers predict WASP-12b will be completely consumed within a few million years, which is cosmic shorthand for soon. It's the first time we've directly observed a planet actively being eaten by its star. In short, WASP-12b isn't just hot, it's melting, leaking, collapsing, and disappearing, all while refusing to reflect light like a proper planet. Black hole accretion disks. You'd think the area around a black hole would be nothing but darkness, but right outside that point of no return is one of the most luminous, violent, and chaotic places in the universe, the accretion disk. It's a glowing, hellish whirlpool of gas, dust, and raw physics, spinning at nearly the speed of light and burning hotter than most stars. Picture this. Matter falling toward the black hole doesn't dive straight in. It spirals, compresses into a superheated disk, where friction cranks up temperatures to millions of degrees. The result is a blinding flood of X-rays, gamma rays, and visible light, all screaming from the edge of oblivion. This disk isn't calm. It's a cosmic blender of magnetic chaos, twisting, warping, and forcing turbulent knots that flare and fade. The gravity is so extreme that light itself bends around it. Time slows, space distorts. It's the closest thing to reality hitting the glitch button. At the disk's inner edge, orbiting matter reaches its last lap. One moment it's racing around at relativistic speed, and the next, it's gone.